Howdy, AP Pre-Cal, it's Miss Kosh. I wanted to follow up on some of the things that I had done in the FRQ2. I was getting confused when it came to questions about, well, here's an example of one. When they get down to stuff like, use the average rate of change, okay, what is it? The average rates of change found in one can be used to estimate the number of cars in the parking lot at a certain time. Will these estimates be less than or greater than the number of cars predicted by the model? And I was getting that wrong or just not understanding things. And so as I was talking through it with the student today in class, I then went to the Facebook group for the Pre-Cal teachers, and I found this worksheet from somebody, and I didn't give them credit. I apologize. I should go back and see who it was that posted this. And I realized that their worksheet, that his worksheet really helped me understand a little bit better what was happening. Okay, so let me talk through some of that. So here's a problem. They give us this equation. They ask us to find the average rate of change. Okay, so that's pretty straightforward. What is greater, the average rate of change on the interval, so from 1 to 7, which is going to, or the interval 7 to 20. It's easy enough to find this. I don't really feel like spending time doing that currently. But what happens is this log function, we should know that this log function has been shifted to the left one. So instead of its asymptote at x equals 0, it's got an asymptote here. And so it actually passes through this and then it grows. But the point that we care about is that it's concave down. And so if it's concave down, the average rate of change is decreasing. So notice, so it's hard to see that, like the average rate of change from here to here is going to be negative, and from here to here it's going to be negative, but not as negative. Okay, so because its average rate of change is decreasing, the average rate of change farther down on the line is going to be less than the average rate of change earlier in the domain. It was one way to say it, maybe. Okay, so let's see. He has the answers down below. Does he agree with us? Yes. So the average rate of change on the first interval, 1 to 7, is greater than. So what I was saying was that this one was less than. Okay, I think those are comparable things. And so then we use the estimate, and it's interesting because I haven't been doing it quite this way, but maybe I should have been. Let's see if this is equivalent to what I've been doing. Let me hang on. Let me take a screenshot of that. And I'm going to just insert this a little higher so I can see the problem and see that, there we go. Go away. Okay, so here's, you know what? I don't need all of this. I'm just looking at this little part right here. Okay, I should have prepared ahead of time. I forgot. My bad. Okay, here we go. But now let's see if we can see what we're talking about. Okay, so here's the point. What I would have done, the way that I work those problems, and this is really to help me understand just as much as it is to help you. I should have done this ahead of time. I did not. Go away. Delete. Okay. Blank slate. I've cleaned things. I've cleaned house. Now I can think. Okay, so what I would look at here is the average. I would say the average rate of change is equal to, well, initially they wanted us to do f of 7 minus f of 1 over 7 minus 1. Okay, and so when I plug in 7, I get 8 log base 4 of 8. You know, one way to do this is say this is log base 2 of 8 over log base 2 of 4. Not the only way to do this, but this 8, here we go, I'll show you all this, what I'm thinking. That's log base 2 of 2 cubed over log base 2 of 2 squared, so this is 3 halves. Okay, and then f of 1, plug in 1. Let me switch colors here. That's 2 log base 4 of 2. Well, 2 is the square root. This is log base 4 of the square root of 4. Square root of 4 is 2, and so this becomes 1/2. So this is 4 to the 1/2. Okay, so we can say that the average rate of change is equal to 3 halves minus 1/2 over 6. So this is 1 over 6. So the average rate of change here. Oh, what did my pen do? I don't know. Average rate of change is equal to, right, that's 1/6. So what I like to do is I just go back and I don't necessarily have anything else memorized. I just say, okay, now we're going to use we're going to estimate f of 10. And so I would say, I would use that same formula, but now using 10 and 7. Okay, so the average rate of change is 1/6. The f of 10 we don't know. F of 7 we did know. That was 3/2, yes. Over 3. Okay, I multiply both sides by 3, and I get 1/2 is equal to f of 10 minus 3/2. Add 3/2, I get 2. So f of 10 equals 2 is how I think through that. What does he do? He takes the average rate of change times, I think this, I've seen this sort of pattern right here other places. 10 minus 7. Okay, hang on. This, we were basically saying 1/6 is equal to f of 10 minus f of 7 was equal to 3/2 over 10 minus 7. So then he multiplied 1/6 times 10 minus 7 is equal, and then we add this 3/2 is equal to f of 10. Is that, does that match what we have there? 3/2 plus 1/6. Yes, okay. So if this right here is something you know and have memorized, then more power to you. It's not coming naturally to me, so what I do is this, and I can't imagine that AP would care. Okay. Here's that I was not uncomfortable with. The part that I was uncomfortable with was part D. And so they're talking about, is the answer an underestimate or an overestimate? Okay, so I knew it was concave down, so I kept thinking, oh, well, the secant line is going to be, if we're concave down, I need more space. If we're concave down, then the secant line is going to be underneath it, so this is an underestimate of the actual value right here. Well, what I was forgetting is that we were going from, here's 1, well, this is when x equals 1, and this is when x equals 7, but then they were asking about what happens when x, this is, it's growing, but anyway, they were asking about what happens when x equals 10. Well, it is beneath the line here, but because this, you can't tell what I mean by this, because this point right here, that x equals 10 is outside that interval, it's going to be above the curve. And this wonderful person who put this beautiful thing together, their graph here all of a sudden made me realize, oh, that's what happened, what's happening. So let me see if I can explain this best to you. When it's concave down, and we have a point here and a point here that we're using to find our average rate of change, the slope of that is that, and the line connecting them is the secant line. So this little yellow line is that secant line. The secant line is beneath the curve between those points because this curve was concave down. But then out here at 10, the secant line is now above the curve. Okay, let's see if he gave an example. Here's something concave up. Okay, so when we're going from here to here, so this was x equals 1 to x equals 5. I haven't even worked this problem. I'm just basing it off the graph. 1 to 5. If I want to know what's happening at 4, so here's my point. This is going to be greater than because it's concave up and it's inside that interval. So the secant line is above the curve. But if they're asking me what happens here at 6, well, wherever 6 would be, somewhere. Okay, here comes that secant line. So it's about here. The curve is it's gonna be beneath the curve. So it's gonna be an underestimate when it's not within that interval. Or if I say, okay, say we take an estimate here at 2. Okay, here's our estimate at 2. This is underneath. That's a smaller value than what the actual value would be. Okay, so all of a sudden, y'all, this is starting to make a little more sense to me. Hopefully this video was beneficial to you. I'm about to crank out as many, that's all I'm going to do on this one. But I'm about to crank out as many multiple choice problems or videos as I can. So come back, like, subscribe, comment, let me know how I can help you. Study, study, study. Bye.